The surface of the moon is scarred with tens of thousands of impact craters of various sizes. Scientists suggest this is due to the fact that there has never been an atmosphere on the moon to help protect it from bombardment by space debris. There are no natural erosive forces, like wind or flowing water, to affect its surface. And there is little geologic activity to conceal damage done throughout the moon's history.
When you study the distribution of craters, you find the surface is totally saturated. That is, that there are craters within craters within craters, right down to the smallest scale of size.
One of the things that's really interesting about lunar craters is that even though some of them are very large and some of them are very small, they all seem to have the same depth. And that really shouldn't happen on a planetary body. There should be variation in depth. So why are the moon's craters so uniform? It's really, really unusual, and it's really not explainable in terms of conventional or established geophysics.
Some of the craters on the moon are nowhere near similar to what they should look like. In fact, they are incredibly wide craters, and wherever the impact point is, they're convex, which means there's still the bulge of the moon, so this doesn't make any sense.
It's likely that there is something under the lunar surface which is very resilient and which is preventing craters going any deeper than they do. This could only really be either much harder rock, which it can't be because of the mass of the moon, or alternatively a metal sphere of some kind which is preventing more damage.
Does the uniform depth of the craters on the moon suggest some sort of metallic barrier underneath moon rock and dust? But if so, why wouldn't mainstream scientists acknowledge this? Ancient astronaut theorists suggest that by doing so, they might also have to acknowledge that the moon may be hollow.
Yankee Clipper, Houston.
November 20th, 1969. During their ascent back to the command module, Commander Charles Conrad Jr. and lunar module pilot Alan Bean release the Apollo 12 launch vehicle and crash it back to the moon.
Apollo 12, Houston, the LEM is on its way down. Roger.
Upon impact, something very unexpected happened. The moon was said to have seismically reverberated like a bell for more than an hour.
With Apollo 12, people referred to a crash. It wasn't really a crash. It was a aimed deorbit of the rocket used to lift off the lunar module. And the crew separated the launch vehicle and crashed it back into the ground right close to where they had a seismograph that they had installed down there. Well, it vibrated, so it was kind of an early clue as to how solid was the surface of the moon.
What was amazing about this is that suddenly the moon began to ring like a bell and did so for nearly an hour. Dr. Wernher von Braun, who was then the head of NASA, decided that for Apollo 13, they were going to intentionally crash a heavier portion of the rocket into the lunar surface. And when they did this, the moon rang like a gong this time for over 3 hours into a depth of over 20 miles.
This was not expected, and it still puzzles a lot of scientists today. The inference is that the moon must be hollow because the moon is made predominantly on the surface of a kind of rock called basalt. Although it's a very lightweight rock, it also absorbs impact extremely well. And so if the whole of the moon was made of that kind of rock, you wouldn't expect it to reverberate when a large impact took place. The reason that this is played down is because the idea of the moon being hollow just contradicts what we know about physics.